It's my pleasure to be here and to talk to you a little bit about fair digital objects in distributed research environments. I know yesterday you talked about democratization of access to high throughput computing, to HPC generally, to OSG. Today we're going to talk briefly, ever so quickly, because I'm between you and coffee, about advancing FAIR in the United States and about fair digital objects and what researchers are doing with them because of policies like the Nelson Memo. The GoFair US Support and Coordination Office was founded in 2019. It's been my pleasure to be affiliated with that office since its inception and to help advance the work of FAIR in the United States. What are some of the unique aspects of FAIR in the United States? We have an ambassadors pillar where we help experts in each kind of research affiliate with and support through training and consultation, disciplinary research for going FAIR. We have focused on FAIR implementation. Those can be practical solutions that match the US funding environment, a lot of FAIR policy and a lot of FAIR implementations will take up the genesis of FAIR among our European counterparts who have involved FAIR in the very funding and policy for things like European Open Science Cloud. Here in US, we have a little more heterogeneous infrastructure for funding and for compute. We talked yesterday about distributed computing and its strengths. Here at GoFair US, we can help you with sector inclusive industry, small business, researcher, funder, appropriate ways to go FAIR. We do outreach consultations. We can help you with lightweight cataloging and metadata extraction. For example, in the National Data Science Fabric project, we're doing just that. We can help with piloting FAIR digital object specifications in your infrastructure. And we can help you adapt metadata for machines workshops to your local scenario so that you can think about helping researchers go FAIR with their research on your systems. Here you see a simplified 3-point verification graph where you see metadata for machines as an initial workshop that is offered. This is a branded workshop that was created by GoFair International Support and Coordination Office because SDSC hosts GoFair US. We have the permission and the collaboration to offer those workshops here in the US as well. At them, we help people develop FAIR implementation profiles or FIPs. You could think of these as grids of metadata choices that disciplines make because platforms don't start from scratch. People already have made choices about their persistent identifiers, about their access, about their findability. What are some of the FAIR implementation goals for NSDF? This might give you an example. Well, we could think of NSDF as a FAIR enabling platform, easy adoption for FAIR community practices, FAIR components that are part of the NSDF value proposition, and the first large-scale infrastructure in the United States to use FAIR digital objects and other novel approaches like this. I think it's a great example of how to take something that exists and see how FAIR plays within it. We also have opportunities with OSG to have OSG FAIR enabling partnerships where existing research being done in OSG can be verified. Briefly, the FAIR principles: findable, accessible, interoperable, and reusable for humans and machines. What's this mean? Really what it means and what the inventors of the FAIR principles intended was that we can achieve an internet of FAIR data and services if we make the things that we're doing in our compute infrastructure interoperable between silos, if we make them reusable between research projects so that we don't fund the same project twice, and so that people can use one another's outputs by finding them, quickly seeing the license for that and the other information that makes them reusable. What are some of the findable goals? To have persistent IDs for each data object, to have schema.org tags for each metadata object. What are the accessible goals? Here we might want to say, how are we going to query metadata via APIs for some of the things that we are putting up? How are we going to make that access open and free across OSG or across any distributed computing environment? We need to think about, if our goal is democratization of access to compute and to storage, how are people going to find one another's resources in that distributed environment? And how are they going to know in a machine actionable way if others' software can touch them and how? This is the bedrock for making this kind of compute interoperable. In other words, how do we make the metadata for each of those output files machine readable? How do we make metadata for config files machine readable? We can do that through JSON-LD, through RDF, and we can use standard vocabularies to define what's in that metadata so that those are referenced to existing standards and facilitate crosswalks. What are the reusability goals? These are the goals for providing an easy way to include license information with output, but also for software, also for workflows, also for vocabularies. If we can do this, what we will see is software able to grab things and know you're licensed to use it and reuse it. This creates a better lineage or provenance capacity in a fair digital infrastructure. And it allows metadata to use standard listed elements from fairsharing.org so that each system doesn't have to brew its own vocabulary or its own workflow. You can reuse others. What are some of the NSDF activities contributing to FAIR goals? Here we see a handful of examples of current work and future work. You might see here, for example, integrating cross-domain interoperability framework, CDIF, with schema.org extensions, with FDO specifications, as ways that we can work together to create more reusable software across research projects and across international collaborations. I participate on the Artificial Intelligence and Data Visitation Working Group at CODATA. And one of the things that group is working on is international policy between countries that allow us to understand one another's training data and to understand whether one another's models can run on whose systems where. FAIR can help with that. And data visitation could be a really important legal mechanism for it. In other words, if I allow legally your software to visit my compute, if I allow your data to be taken up by my model, I can do that in a legal way that is lighter weight for periodicity and easier to facilitate than a file-driven policy where I say, so-and-so has access to this file on this date for one job. So data visitation can help encourage an ecosystem of fair digital objects. I want to thank you for your attention and to draw your eyes to this kind of sketchy fairdo.org over here on the right. In March 24, there will be a conference on fair digital objects that San Diego Supercomputing, West Big Data Hub, and several other sponsors are bringing together with international experts as well to help advance this. We'll be through Go Fair US, showing opportunities to participate and learn from that event. And we really welcome your participation and encourage you to keep an eye on fairdo.org and Go Fair US, so that if you need consultation to meet these funder mandates, or if you need implementation workshops to help make decisions, you know we're there. We're funded to support you. We're there to advance FAIR in the US. And it's our goal to help you when you see the Nelson memo policy, when you see the opportunity for advancing open science in the US through democratization of access to compute. Think about these fair digital objects and how they can help in that infrastructure to allow us to do sharing at the data level so that we can use one another's research more quickly and not only conserve resources, but hopefully advance one another's work as well. Any questions from anyone about FAIR, about FAIR-DO, or anything I've mentioned so far? I know it was lightning fast.